Learning about behavioral variant frontotemporal dementia. Frontotemporal dementia involves neuronal damage in the frontal and temporal lobes, which cause these areas to shrink. Behavioral variant FTD is a subtype and occurs when there is a buildup of abnormal proteins including tau, TDP43 and FUS in brain cells. Symptoms involve behavioral and personality changes such as inappropriate behavior, becoming socially withdrawn, lack of interest, psychotic symptoms, compulsive behaviors, and deficits in executive functioning. Symptoms typically begin to appear during the age of 50. In most cases, the person with the disease is unaware of their behavioral changes. About 2/3 of behavior variant FTD cases are sporadic. Sporadic cases are when a person develops bvFTD with no known family history or genetic mutations, it just appears with no cause. There is often a later age of onset with sporadic cases compared to genetic cases, but both involve similar symptoms. 1/3 of cases are related to genetics or autosomal dominant mutation, meaning a person only needs one mutated gene from their parent to be affected. There have been 3 identified genes that, when mutated, can lead to this disease: MAPT, C9orf72, and GRN. The first one is the microtubule-associated protein tau, MAPT. This causes abnormal tau proteins to form clumps and tangles in the brain cells. They begin to accumulate near synapses, which cause them to fail, meaning neurons cannot communicate as efficient. Due to tau buildup, neurons become stressed, leading to cell death in frontal and temporal lobes. The second one is the C9orf72 gene, which is the most common genetic cause of bvFTD, affecting 36.4% of people. With this mutation, there is a hexanucleotide repeat expansion that occurred, meaning that DNA letters were copied too many times. This affects how the gene works by causing a buildup of toxic RNA and proteins, which lead to damaged nerve cells. With this gene mutation, it's possible to have ALS either by itself or combined with bvFTD, as they share the same pathology. Patients may also show psychiatric symptoms, including psychosis due to molecular toxicity and damage to specific brain areas. Lastly, the GRN gene mutation has a later age of onset and accounts for roughly 20 to 25% of cases. When a mutation in this gene occurs, it produces lower levels of progranulin protein, which is needed for cell growth, repair, and survival. This deficiency is linked to cause an accumulation of TDP43 proteins that form clumps in brain cells. Due to this buildup, it can lead to nerve cell death, resulting in brain shrinkage of the frontal and temporal lobes. The volume loss is asymmetrical with this mutation and slower in the beginning, but once symptomatic, it accelerates quite fast. For diagnosing, patients must meet 3 of 6 behavioral and cognitive symptoms. Neuroimaging is done to identify atrophy in the frontal and temporal lobes. Additionally, neuropsychological testing is followed to reveal executive dysfunction, along with biomarkers to rule out Alzheimer's, and genetic testing to identify any gene mutations. Currently, there is no cure for this disease, but symptoms can be managed with pharmaceutical treatments, structured routines, changing environments that influence impulsive or repetitive behaviors, and caregiver well-being. If you need assistance or support with bvFTD, visit Rare Dementia Support Canada or Alzheimer's Society of Canada.